Okay, class. So, aside from the limits, okay, we have here the continuous function. So, how can we say that a given function is continuous? Okay, a function class is continuous when its graph is a single unbroken curve. Take note the term unbroken. Okay, yung say unbroken, there is no point where hindi sila magka-connect. So which means all the time connected sila. Okay? That's when we can say that that function is continuous. For the term itself, it continuous. It continues. Okay? Now, the other way on how we could determine if a given graph is continuous is when you use your pencil or when you draw its graph, you don't lift your pen from the paper. Okay, when you trace it, you don't lift your pen. It's because it is continuous. Okay, so that's how we can determine if the graph is continuous. Just like what you can see there in your picture. That's an example of a continuous function. Now, we have here an example of certain functions. How to determine is it continuous or not. For the first picture, what can you notice? We can notice that there is a hole, right? Hole, or an open hole or hollowed hole. So, if that's the case, although the line is continuing, but there's one hole only, can we consider it as a continuous function? The answer is not. Okay, a function is not continuous if there is a hole in it. Okay, also, if there is a jump, when you say jump, there is a portion where, as you can see here, although there's a line here, there's a graph here, but there's portion here where you have to literally jump from one point to that point. So that is also not continuous, literally. And if there is a vertical asymptote, if you could recall in your geometry, analytic geometry, in hyperbola, the graph of a hyperbola, so there is an asymptote, right? So if there exists an asymptote, just like this, as you can see here, that function is also not continuous. Okay, so that's some of the common physical signs that we can say that a function is not continuous. Now, we have here this one. Okay, if you could recall, class, in our previous topics of function, we have determined the function or the domain, right? We have said that that domain is the value of x. Let's say, for example, you are given f of x. So domain refers to the values of x that can be inputted in your function without any rules or laws broken in math. Okay? Or those are values of x that defines our function. Now, we can say, class, that a function always has a domain. Okay? And like we have said, dapat yung value na yun is okay siya sa function. Now, this domain, class, we have to choose that value to determine if the function is continuous at that part or not. For example, this one, class. This one. We are given f of x is equal to 1 over x minus 1. Okay. Just by looking at the equation, what do you think are our domain? Is it all real numbers? Can we substitute positive numbers in here? Yes, we can. But there's a limitation, right? What is that limitation? We cannot use positive 1, right? Why can't we use positive 1? What will happen if you substitute positive 1? If you substitute positive 1 here, our equation will become undefined, right? So which means if the given number or given value is undefined at that point, which means there is a discontinuity at that point. Kasi hindi natin hindi connected yung line eh. Kasi di ba yung graph class, it should have, it's like katulad nito class, ito. Di ba? If this is the domain, okay, if this is the value of x, the value of y is this. Right? So this is the graph. If this is the x, then this is the y. There is a corresponding in one value of x, there's a corresponding y. So if a value of x doesn't have a corresponding y, which means that is not the graph. For example, this one. Let's say this is the given graph. Okay? Let's say your value xx is here. This one, let's say 1, for example only. Now, if you trace 1, is there a corresponding y in the graph? There's none, class. It's because at this graph, the x is only here, which means that the domain is from here up to here only. So therefore, values of x which is below or going there are not included. Can you follow? So therefore, there's no corresponding range or there's no corresponding output, which means it is undefined at that point. Now, going back to our example here, we have said earlier that if we put or if we substitute 1 to our equation here, it is undefined kasi magiging 1 over 0. So which means at x equals 1, our function is undefined, which means at that point, there is a discontinuity. Okay, so take note of that, class, that once our function is undefined, okay, which means there is discontinuity. And what does it mean, ma'am, if there's discontinuity? Which means that your function is not continuous or your graph is not continuous. Kasi nga discontinuity may part or may portion doon na naputol. Can you follow? Kasi class, although ganito, no? Halimbawa ganito. Ganyan. Can you consider that as continuous? No, you can't. Although the graph is continuity or continuing, but there's a portion na nag-stop ka Ayan may portion na nag-stop ka. So which means hindi na siya nag-continue. Although after that point na nag-stop ka is pinatuloy mo pa ulit, still it's not considered as continuous. So even if one part lang, class, na putol or may hole dyan, considered na siya as not continuous. Okay? I hope na nakukuha nyo. Another, what if na binago natin yung domain? Kasi kanina, di ba, yung domain natin is all real numbers, sabi natin. Kasi pwede yung positive pwede yung positive, pwede yung negative, pwede yung 0. Except lang sa positive 1. Kasi nga, sabi natin, at positive 1, maging undefined siya. So, yung domain natin dito is all real numbers. Now, what if baguhin natin yung domain natin? The same equation, pero what if our domain is x greater than 1? What will happen? Now, if you substitute here, puro positive yung i-substitute mo. Kasi x greater, take note of the term greater. Is positive 1 included? No. So, pwede ba? Way back in our equation, can you substitute here positive numbers? Is it defined? The answer is yes. And therefore, Therefore, it will be continuous. Okay? So, pag yung domain mo lang is positive 1, greater to 1, it will be continuous. Pero pag all real numbers, hindi siya magiging continuous. Kasi nga, at x equals 1, it is undefined. Nakukuha niyo ba, class? Nakukuha niyo? So, from here, we can conclude that in order for us to say that that given function is continuous, if your function, or for every value of c in its domain, they note your c here represents your domain, or a certain value from your domain. If you substitute that in the function, it should be defined. Take note. Okay? For any value of c. Again, this c refers to your domain. So, halimbawa, yung domain mo is all real numbers. So, substitute ka, positive, negative, 0. Now, if you substitute a positive to the function, so, di ba magiging ganito siya, f of c. You substitute the c to the f of x. Yan. So, defined ba siya? The question is it defined? That's the first condition. Pag yan, nag-defined, or meron siyang value, which means continuous siya. Okay? But, pag sinubstitute mo yung value ng c sa function mo at yung lumabas is undefined, automatic. Your function is not continuous. Can you follow? Not continuous. That's the first condition, class, ha? So, you need to check this na dapat defined siya. Pero once na hindi na, stop ka na. Okay? Kasi class, dalawa yung condition na to. Dapat, both of these conditions must be met. So, kung sa una pa lang, dito pa lang, nag-undefine na siya agad, so automatic, masasabi mo na siya, o i-conclude mo na siya na not continuous. Pero halimbawa, no, dito, defined siya. Okay? Okay, so proceed ka sa next condition. Dapat daw, the limit of that function as x approaches c should be equal to f of c. Ano ibig sabihin? Dapat daw, yung limit must be equal to the value of the function at that point. Kung ano yung lumabas dito, dapat equal din sa limit. Pag kinuha mo yung limit at that point. Okay? So, pag okay yan, pag nag-equal sila, therefore, na-met mo yung dalawang condition. So, once you met that two condition, therefore, you can conclude that your function is continuous. Again, class, I want to clarify that dalawa yung conditions, ha? So, kung yung isa dito is hindi ma-met, automatic, the function is not continuous. Okay? So, dapat defined and it should be equal to its limit. So kung mag-undefined yan at hindi equal yung limit, automatic. Kahit isa lang, ha? Na condition na hindi umamet, automatic na yun. Okay? So, for example, for that is this one. There. Sa graph pa lang, class. Okay? Sa graph pa lang, oh, may hole. Take note. May part or may portion doon na, ayan, oh, may hole. Diba sabi natin, once the graph has a hole on it, automatic, it is not continuous. Okay? So, kahit halimbawa, paano pag walang graph? How will we know? Paano kung equation lang yung given, katulad nito? For this example, we are given function f of x, and this is the equation x squared minus 1 over x minus 1. And you are to check for the domain all real numbers. So, diba sabi natin, all real numbers is positive, negative, and 0. Now, try substituting those numbers. Can you substitute positive? Yes, but except sa 1. How about negative? Yes. How about 0? Yes, pwede siya. So, meron kang isa na hindi pwede, which is which is positive 1. What will happen if you substitute positive 1? Your equation will become undefined, right? It will be undefined. Oh. So, dyan pa lang, i-undefined na siya. So, therefore, not continuous. Tama? Oh, that's the first condition. Second condition. Ano nga ulit yung second condition natin? We're gonna check its limit. Kung equal ba siya sa ano niya, sa function niya. Eh, di ba sabi natin, sa first condition pa lang, undefined na siya. So, bakit ka mag-proceed sa limit niya kung sa una pa lang is, alam mo na, not continuous, di ba? Pero let's check. Let's check, class. Ano yung limit ng equation na to as it approaches 1? Ayan, oh. Ayan. Ito yung 1. As it approaches 1 from the right and from the left, what happens? Is there a limit? It is undefined. Bakit undefined din? It's because whole nga siya. Walang value. Can you follow? So, therefore, very confirmed that it is not continuous. That's why, class, you really have to check. Okay? You really have to double check. And by the way, when it comes to checking the limits, so remember that when it comes to limits, dapat both sides approaching from the right and approaching from the left, they should have the same value. Okay? They should have the same value. So you should check it. Okay, so what if, class, we change the domain of our previous example? Okay, so earlier, our domain is all real numbers. So we have said that at x equals 1, it is not defined, it is undefined. So therefore, there is discontinuity, and therefore, we can conclude that it is not continuous. And also, if we check the limits, so the limits is undefined also. Now, what if we change the domain? Instead of all real numbers, what if we use x which are less than 1? Which means 1 is not included, but rather we use 0 and negative numbers. Will it be continuous? So the answer is continuous. Why? Because if you check it here, class, here, so values which are less than 1 is this one, right? As you can see, it is continuous. And if we substitute also x which are less than 1 here in our equation, then it is defined. That's the first condition. So once you substitute values which are less than 1, your function is defined, therefore correct, or therefore it is continuous. And also, class, if we check our limit, okay, if we check our limit, it is also defined. There's values. So therefore, we can really conclude that at interval x is equal to less than 1, then our equation or our function is continuous. Class, do you get or can you follow now? Okay? So, pag mag-define yung yung function natin or may definition siya at that certain domain, then we can conclude that it is continuous. But if not, then not continuous. Another example, this one. What if piecewise naman yung function natin? When I say piecewise, class, diba I have discussed this to you in our function. It is defined in 2 pieces or two pieces or more. For example, here, h of x is equal to 2 if your x is less than or equal to 1. Or h of x is equal to x if x is greater than 1. Okay, now, this function, class, can be graphed as this, or it will look like this. This one, 2 if x is greater, less than or equal to 1. Saan ba yung x natin na 1? Ito, take note, less than or equal to, which means included yung 1 mo. So, yung value daw ng h of x mo or yung y mo is 2. So, all the time, 2. That's why ganyan yung graph niya. Tapos, meron tayong filled hole dito. Now, eto naman, x is greater. Take note, greater than 1. Okay? Which means, na to the right side naman siya. And then, your value of h of x is x. Yan. So, this will be the graph naman. Now, take note na meron tayong open hole dito which tells us that it is not included. Now, the question is this a function continuous or not? The answer, class, by the looks of it, automatically, the function is not continuous. Why? Why? Kasi, class, by the looks of it, meron tayong jump. Aside from the jump, meron tayong hole. Diba? Hole and a jump, automatic, not continuous. Okay? Therefore, and also plus, at x equals 1, okay? Masasabi natin na defined siya. Bakit defined? Kasi at x equals 1, meron siyang value. Right? Meron siyang value of x. Y rather, defined siya. Pero, when it comes to limit, it is or it doesn't exist. Bakit doesn't exist, class? It's because the limit in both sides are not the same. Why not the same? It's because if you approach 1 at the right side, what's the value? It is 1. How about from the left side? What is the value of the limit if you approach 1 from the left? The value is 2, which means that they are not equal. So therefore, the limit does not exist. So once that the limit does not exist, although defined siya, still not continuous. Kasi we have said, dapat masasabi lang natin na continuous siya if it is defined and the limit exists. Okay? So ayan. Another example. Okay, this one. Another piecewise, different even. We have f of x is equal to absolute value of x is equal to negative x if x equals less than 0, and x is positive x if x is greater or equal to 0. Okay. Now, looking at the graph, what can you observe? Is it continuous? Yes. Why? Because if you trace, class, there's no hole, there's no gap, there's no jump. So, automatic, continuous. And if you check if it is defined as, if you substitute less than 0, which means mga negative numbers sa equation natin, is it defined? Yes. What if you substitute positive numbers including 0? Is it defined? The answer is yes. What if you take the limit? Let's say at x equals 0. As you approach from the right side, is there a limit? Yes. And what's the limit? 0. Right? How about from the left side? If you approach 0, what is the limit? The answer is still 0. Therefore, the limit exists. Why? It's because the limit are the same both sides. That's why we can say that the limit exists. So therefore, from this class, we can conclude that the equation or the function is continuous. I hope, class, that naintindihan nyo. Okay? So dalawa lang. Again, I want to clarify, I want to conclude that 2 conditions must be met. It should be defined and the limit should exist.